So let's look at the laws that govern how compounds form. So be able to define the law of definite proportions, which, to quote the book, states that in samples of any chemical compound, the masses of the elements are always in the same proportions. And then, of course, define the law of multiple proportions, which is, to quote the book again, whenever the same two elements form more than one compound, the different masses of one element that combined with the same mass of the element are in the ratio of small whole numbers. Yes, these two things are kind of different. Anyway, use the law of definite proportions to calculate the ratios between elements and use the law of multiple proportions to understand how different compounds form. So we're going to skip some sections of your book, such as the mass ratio and practicing skills is going to be a class project rather than, a lecture component. So go back to Dalton's atomic theory if you want and look at how atoms of different elements can combine to form compounds in simple whole number ratios. That's basically your law of definite proportions. This is what Dalton would find, that in carbon dioxide, you always have one carbon to each two oxygens. Or in sodium chloride, you're going to have one sodium to one chloride. So let's say you take a chunk, you're going to have an equal number of sodium and chloride. But what if you got like an uneven number of atoms? Well, then it's not really a compound at that point. It's going to be charged. So that would not be the full compound if your little chunk had some sort of uneven number of atoms. Think about what type of compounds would be most useful for, and you're probably going to think of your ionic crystals, of course, or pretty much anything where you're dealing with simple cation-anion interactions. And you remember the ratios that we looked at and how crystals form, then you're doing great. Well, what about the law of variable proportions? These compounds have different physical and different chemical properties. So you have, just for sampling, copper 1 chloride is green, copper 2 chloride is blue. Just these different colors are one very clear, different physical property. They do have different chemical properties as well, such as the charge on the copper ion. And this is when the same two elements can form more than one compound. Some examples here would be your different covalently bonded molecules. So look at NO and NO2 and N2O3 and N2O4 and N2O5. Yeah, these are different proportions, and those are going to have different chemical properties between them. Also, when you think about acids, and you have the ic and aus acids, or the different ite and ate compounds and molecular compounds. Or, of course, as you saw with copper, the transition metals that have different charges like iron 2 and iron 3, both of which can form an oxide.